make you so special? Why did he bless you? Think about it. I woke up this morning. Got a smile when I say that shit. I woke up this morning. Go.
And we're live with Joel Geders, which is this episode is a continuation of the last episode, number 44.
I'm back, motherfuckers.
So we left on the quantum eraser, and you were going to explain the double slit.
Okay,
Wait,
so
it's double slit what?
double slit experiment is like one of the most famous physics experiments of the last century.
Right.
So
take this off.
Due to a lot of the new theories that came out in like the early 1900s, in terms of like quantum theory, like the Heisenberg uncertainty principle, a lot of other like really revolutionary ideas in physics, people were starting to ask all sorts of questions about the fundamental way that matter behaves, because there were starting to be shown in the math that when you break things down to a certain degree, there's not that much of a difference between photon, which is like a bundle of light, like energy,
Right.
and like an electron, which is a piece of matter. Like there were.
Can you state that one more time? What was the distinction between the electron and the photon?
Simply, electron is a piece of matter, a very small piece of matter. A photon is a very small bundle of energy.
Okay.
But what they were starting to see with certain quantum theories is that, like, under certain conditions, the two, even though they're fundamentally different objects, at least in the way that our brains had been conceiving of them for the past however many hundreds of years, could behave the same. So the double slit experiment is like one of the big things in this whole phenomenon. So if you shine a light through one slit, like you'll just see a slit of light on the other side.
Okay.
When you shine a light through two slits, you get what's called a wave interference pattern. Like, you can look it up if you want to.
Does it bend light?
It doesn't bend the light, but basically the light behaves as a wave. So what happens when it goes through those two slits is the wave splits, and it goes forward as two separate waves through those two slits that interfere with each other.
Does it recombine?
Well, that's how you get that interference pattern. The waves don't necessarily recombine as much as they interact with each other in such a way that, like, just look it up real quick. It'll make this really easy for me to explain it. But what happens more or less is, so instead of getting two lines of light on the other end, you get a bunch of bands of light, which you're probably about to see on there.
Is it like a video or an image?
Just an image. Double slit light pattern.
The grapes.
Well, okay, yeah. So this will help. So this is for an electron. So this is a step further, but to stay where we are right now, imagine this were a light. You would get this pattern. If this were a light source instead of an electron source, you would get the same pattern. And that was the big thing about the double slit experiment, because wait,
I don't understand it. So there's an electron going through two slits.
Well, yeah.
Double slits.
Let me get to it. Let me get to it. So, like I said, when you put a light through one slit, you get you'll get one band. When you put light through two slits, the wave, like the light wave, splits, and the two waves interact with each other on the other side of the plate here. And there's this thing that takes place called interference, basically where certain parts of the waves meet each other and they cancel, but the waves don't completely cancel out, so you get like this kind of pattern on the other side instead of just seeing two slits.
This is so confusing to me. I'm sorry.
Nah, it's all good. It's all good. This is like really heady shit.
Okay.
So, like, okay. So, can I draw this again out for
totally,
you?
Totally.
So, I wish I could find that page I drew on earlier, so I'm not.
Cool.
Fuck it. All right.
There will be more notebooks.
So when the light goes through these two slits here,
Right.
And you have a screen to receive everything on the other side. So there's one wave. These lines represent a wave. One wave going through. What happens when it goes through the two slits is the wave gets split. And as it goes out, it fans out. And both of them do this. So what happens as they fan out is certain parts overlap and cancel each other out. So instead of seeing just two lines on this side because of certain, or just like, a band of light on this side, because those spots cancel, you get like a line of light here, 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 like corresponding to basically like what parts of that wave didn't interfere with the other wave. So so you end up with that pattern.
Okay.
And why they show an electron here, because you're like, well, wait, if that's how light behaves and light is energy, what about an electron? Electrons matter. So when they put an electron through a single slit, you just get one slit on the other side. Like, basically the electrons form a single slit on the other side. But when you put an electron through two slits, you get this exact same pattern.
So basically, for anybody listening, it's a double slit, which is the first.
So when you shine light through two slits, you get this basically a bunch of vertical, or you get a bunch.
On here, it's 5 different slits.
On the second screen. The number of slits is really kind of arbitrary and determined by how far out you go, because if you notice think about it, like the further lines out aren't quite as intense, so like I said, light is a wave, and the wave is going to propagate over space from its source. So the further away from the source you get, the further the wave is going to spread out.
Totally.
And that's actually why the further you get away from a light source, the less you notice it, because the intensity of that light as you're experiencing it is spread out over a longer distance.
Wow.
So it's gonna
be a lighter shade than what would show on the first screen.
Well, so the center is going to be a thicker band than towards the outsides of it, which are a little bit more faint. And what I'm getting at is, so that whole the wave fanning out over space, that's what happens when you put the light through two slits. Is the wave splits into two waves that fan out over space, but as they fan out, they run into each other, and those spots where they run into each other are where the dark spots come in here. The spots where they move unimpeded is where the light bars come, where you see bands of light.
Okay.
So that's light. That is energy. That's the way energy behaves when you put it through two slits. And where the mindfucky part comes in is...
goodness. We haven't even got there.
Yeah, exactly. Electrons are pieces of matter, little bundles of matter. When you shoot them through two slits, just like how they show here, you get the exact same result as if it was a beam of light. So, think about this. If the electron were just a single particle,
right,
or if the electron were behaving like a single physical particle, it would go through one slit or the other. Okay. And you'd get two bands on this side. Or you'd get two bands on the screen on the other side.
How would you get two bands if it's going through?
Well, think about it. If it's just a simple particle, think about it like a particle should behave like you're throwing a ball through two separate little hoops. Think about it like you got a tennis ball and a Velcro wall on the other side, and between you have two little hoops to throw through.
Okay.
Your ball, because of those two hoops, the idea with how this experiment was supposed to work is you're going to throw a ball through one of those two holes, and you're going to get, because it's going through one of those two holes, you're going to get basically two lines on the other side, or two groupings of matter on the other side.
Okay.
But they didn't. They got the result that would happen if the electron behaved like it were a bundle of light. The electron matter behaved in a wave fashion like light, like energy. And so you get this pattern. The reason you get this pattern on the other side is in the space between here and here and here and here, the electron goes through every possible, like basically in the double slit experiment, it shows that, first off, matter behaves like energy at small fundamental levels, A, and B, that to a certain degree, like, matter, what we thought was this finite thing, like for this to be possible, it has to go through both slits, neither slit, every single thing that you could think is possible. Literally every describable reality for what the electron does is possible. And like I said, including not going through either slit at all.
Wow. So are they able to explain how this works? How the electron works like a photon?
Well, that's the thing, is like, when you get down to it in quantum theory, like in terms of the mathematics, that's kind of the point this proved, is that mathematically an electron and a photon, a basic like tiny bundle of matter and a tiny bundle of energy, aren't fundamentally that different. They exhibit similar behaviors, similar patterns.
Okay.
And so like, why I like bring this up, so that quantum eraser thing I was talking about, because last time we talked about like quantum computing bridged into quantum coherence. So, in like the weird world of science, so they recently did a variation of this experiment, because they've been running it for decades, trying to improve it, figure out conditions. Like, they've been trying to explain all of the results for this for decades.
Wow.
Like, we still don't fully understand everything that happens here to a certain degree.
Right.
Because they've observed this effect happening even with like large molecules. These things called buckyballs, which are like basically balls of carbon atoms.
Okay.
They've like whole molecules. Like, we're talking like on the atomic scale, so that's like, you know, a pinhead. We're talking molecules that are the size of, relative to that, like a grape or larger.
Oh, wow.
Exhibit the same behavior under certain conditions.
Really? So is it the I guess chemical makeup? You ate it. the chemical makeup of that carbon, that's and the size doesn't really differentiate the behavior of it, or? Well,
it's just more so further to the point that like matter behaves like energy under certain conditions. Like, we think of matter as a like, you know, we think of this pen as a finite point in reality that occupies a set space. But say the electron is a pen in this situation. Between here and here, and between here and here, this pen is not a physical object, but a wave that occupies a certain set of space.
So this seems to... I feel like I'm not fully understanding or wrapping my mind around like what this could mean, but what it kind of seems is the possibility of teleportation, like we were talking about on the last podcast.
Well, so like that's my thing, and kind of why I brought this up is like a lot of the questions for what we could do are still so up in the air because of all of the possibilities about just the fundamental factors of like the quantum world. So going on into this, you know, I'd mentioned like the quantum eraser. So the quantum eraser is a version of this double slit experiment where they tried to figure out, like, because there are certain aspects of this whole experiment that seemed to violate certain, like, concepts that just were fundamental to our understanding of physics. I mean, like
laws of physics.
Yeah, like, we had basically kind of been an unwritten law that matter and energy fundamentally behave different. I mean, like, to a certain degree, if you want to consider, like, mathematical equations of classical physics laws, we actually had laws that were like, these are fundamentally different objects that behave fundamentally differently. And suddenly we find out, like, no, that's wrong. Like, and okay, the fucked up part of all, let me explain this. So at first they tried this with shooting just a bunch of electrons out. And they got this pattern. They're like, well, what if we just shoot one electron at a time so that they couldn't possibly interfere with each other? They got the same result. They got this result firing
What the fuck?
Yeah, dude.
One electron is going through double slits?
One electron is going through both slits, neither slit, and just magically teleporting onto the other side all at once. Like, and every possibility inside and beyond that.
That is the most indescribable thing I've ever heard in my life.
It gets weirder, man. It gets weirder. So this version of the... you should probably look up a description real quick, because I know I'm going to fuck this up.
Okay.
Look up quantum eraser experiment, but basically they were kind of like trying to determine like what exactly does the electron do, or does the particle do in this experiment that causes this behavior. And there we go.
Should we read it out?
Yeah.
A delayed choice quantum eraser experiment first performed by, Yoon Ho Kim, shout out. I'm not going to name all the people.
R-U-P Kulik Y-H She, I think, and Marlon O. Scully.
Respect. I was about to give up.
And reported in early 1999 is an elaboration on the quantum eraser experiment that incorporates concept considered... okay, yeah, this isn't going to help people out. Diagram time. Oh, sweet.
Bang, bang. Yeah. Oh, there we go. Oh, wow.
So what they do is...
No, you're fine. I'm just writing down the time, so I'm gonna like overplay a image on the video.
Okay, I got you.
17.
So essentially, like I said, they were kind of like trying to figure out what exactly is going on in this whole, like, because one of the implications of this whole experiment is that, like, in that space between between whatever generates the particle source and the screen that detects where the particle hits, a lot of things are possible. A lot of things are possible.
Right.
And they wonder, like, they did all sorts of things to try to figure out what's happening, but whenever we try to directly observe what happens to the particles, the funny thing is, we actually end up getting just the single double slit. The simple double slit, I should mean.
Say that one more time.
So, when you do the double slit experiment, so one of the first things they did to try to figure out, okay, what's going on with the particles, they did a measuring device on either side. They've done variations of the experiment where they put a measuring device on either side of the slit, like two slits, to try to like physically see what the particles are doing. But it turns out our instruments that we use to detect them influence that quantum information such that we end up just seeing a regular two slits. So when we don't have anything observing that space between generation and detection, we get an interference pattern, an energy pattern, a wave pattern, something completely mind-fucky to us. When we do that same experiment, but other than the detection screen on the other side of the slits, we add in additional measuring devices, we see it behave just like normal matter with two slits.
Okay.
So we've done all these kinds of crazy things to try to basically... Because some scientists have said, like, it's almost like the universe is on to us trying to figure out its tricks. So we've done all these types of...
It just switches up everything.
Yeah. And we've tried to do all these crazy experiments to basically, like, get around nature trying to trick us and keep us out.
Right.
So this experiment is one of those ways. So... as you can see here, there's like, the laser beam generates the laser beam generates a source. It goes through the two slits, and then one of them is put into a beam splitter. So, like...
Is that what the BS says?
Yeah.
Okay.
So... Oh, God. This is so... Like, this is very difficult to get at with this... Let me see if there's a better diagram real quick. Sorry.
No, you're cool.
Oh, perfect. This explains everything.
Oh, there we go.
Nice. Okay. Dope. So yeah, this light source sends 2 photons through the slits.
So this A right here, or that's a slit?
Yeah.
Okay.
So A and B are slits, and then this is a well, it says it right there. It splits each photon into 2 identical photons. And when it says entangled there, what that means is this quantum effect that we've shown that basically, like, 2 particles... Okay, this is its own mindfuck on its own. We can get into this too if you want, but quantum entanglement is this concept. Einstein fucking hated it. It's hilarious because, like, it's actually a consequence of some of his equations, but he fucking hated it because it violated certain principles of our universe, such as locality. Basically the concept that, you know, this grape can only influence things immediately around it. Like, this grape has no influence on something in a whole nother galaxy. That's the principle of locality. The other thing, I keep using grapes for these references. It's great. Grapes were a good idea. But I can't remember what some of the other principles were, but, like, quantum entanglement is this notion that any 2 particles that are entangled by some original event, like they have some initial interaction that makes them connected, be it a chemical event, something like that, or in this case, it's one bundle of energy that's split into 2, they end up having this effect where, say, if photon A is here with us and photon B is off in another galaxy, if I spin photon A, our photon here one way, without any delay, there will be an immediate noticeable effect on photon B across the...
How? Yeah.
Well, like, you could probably write you could, if you could answer that question succinctly, right, you could get, like, every prize in physics.
Right. Wow.
Like, but, like, one of the things that implies is, like, this concept that fundamental to us is, like, the concept of locality. The concept that, like, you know, I can only influence what I can touch. But it turns out that at the fundamental level, our reality influences itself in ways we couldn't comprehend. Like, and one of the, like, real implications of this is, like, or one of the real, like, interesting things about this is, if you think about it, there's a question, if the Big Bang Theory is true, was that an entangling event?
What do you mean with that?
Well, so, like, an entanglement event is something that links 2 particles in such a way that they are considered entangled. Like, they experience this phenomenon of no matter how far apart you separate them, you can influence information on one by altering information on another, regardless of distance, and it will be instant.
That's just so mind-blowing.
Well, and so, like I said, there's, like, a question then. Is the Big Bang considered an entangling event, and therefore is every particle in our universe connected in that sense? Because, like, we like to think that, you know, things...
everything's separate.
Yeah. Well, and going off of that, there's actually an...
Is consciousness connected? Sorry, I cut you off.
Well, no, I mean, that's the whole point. Like, to what degree is our reality connected to itself? Like, there's this one guy that, like, said, you know, so what the state that the particle exists in, like, the double slit experiment, where it's, screw it, between the particle source and the detection, it's in the state called quantum superposition, which means that it is in literally every possible place it could be. Like, and I mean, we're talking like it's here, and like everywhere in the universe that's not shown on this diagram.
Wow.
Like, I mean, like theoretically, that is the state it occupies. It is every possible place it could be. Now the thing is, like, everything has our universe kind of runs on probability, and so like every possible position contributes to the probability of where it is. So it's messy. But like, there's this whole hypothesis out there that basically states like, what if our entire universe is like, so that superposition thing, you know, the particle is doing everything, including like interacting with itself. And that's like any time the particle is unobserved. Because when we put in, like I said, when we put in observation equipment, the particle snaps into behaving like normal matter. You get two bands on the screen, and it basically collapses the quantum superposition. But so something unobserved, though, exists in that nebulous infinite state. And there's basically this hypothesis out there that's, what if our entire universe is one single unobserved particle interacting with itself in every possible iteration that it could embody across space-time?
I don't know. I guess it is kind of plausible if based on everything else that you've said so far.
It's only a hypothesis, but
right?
Like it's actually a surprisingly plausible one.
Based like if you would have just said that at the start of this podcast, I would have been like, I don't know about that. But based on like the that's what I'm still so like brain broken, just mind blown on the fact that a photon can be here and then over in Europe right now or wherever, anywhere else in the universe, and like theoretically everywhere in the universe.
Yes, and theoretically anything that is unobserved is everywhere. Including not existing at all.
And this kind of ties back into isn't it like Buddhist philosophy, like all is one is all kind of deal?
Well, yeah, I mean, it's kind of funny, like, because like if you look at like Buddhism, because there's a little bit more formal doctrine to it, not so much, but like if you really read like Taoist texts, like one of my favorite lines of Taoism is one of the first lines of the Tao Te Ching, and that is, the Tao that can be named is not the eternal Tao. Like, and basically the Tao in Taoism is like this indescribable universe that is forever beyond us, that if you claim to understand, you have no clue of.
Right.
Like, and like it kind of states like every different, like that's why I mentioned to you earlier, like I don't like binary logic. That's why that's a large part of where that whole thought process comes from, because like our reality is so much, it's so much more than is it this or that. This or that is a construction we've made. Our reality clearly is a lot further beyond that. Like, is it matter or energy? Well, it depends. Like, and sometimes it's neither. Like, and so getting back to this before I forget it.
Or sometimes it's both. Maybe?
Yeah, no, like seriously.
It's just any possibility.
Exactly. Like that's like the implication of quantum theory is like at the fundamental level. Like, okay, according to quantum theory, between that little pause I took there and the time between the last word I said and the next thing I said, for all intents and purposes, I could have gone to Mars, come back, and like teleported to Mars, come back. That's theoretically possible. Now, like I said, the universe runs on probabilities, and due to the nature of the particles that make us up and the way they interact, some things are a lot more probable than others, and therefore end up being the reality. But that doesn't mean that the less likely things are impossible.
They're just less likely.
Exactly. like, the chance of me staying in this seat right now is far greater than the chance of me being teleported to Mars. But that's not to say that theoretically it could not happen. Under the right conditions.
If it happens, is there any time that has lapsed? Or is it just so instant that, like, I'm not even able to, like, perceive it?
Well, so that's a whole other question, because, like, that's one of the things that this experiment really, like, the quantum eraser experiment got really famous for. Why it's called the quantum eraser, basically what happens is, so you send the photon through, you split it so you have pairs of entangled particles going off in different directions. So here, the D's here stand for detectors. So you have all these detectors here. And like I said, what they're trying to do in this experiment is trick the universe. They're trying to basically make the universe think they aren't observing something they're observing. And this is one of many in a series of experiments that, like I said, is trying to explain that difference between the wave interference pattern of unobserved electron double-slit experiments and the simple two-band pattern that you get in observed double-slit experiments. What explains the difference in its behavior strictly due to the observation? And that's what they're trying to figure out here. They're trying to... So you have detector 1, the beam split, and you have entangled pairs. So what that means is you can infer the information of one from the other, basically, because of how they're linked. To a certain degree.
Okay.
Like the simplest way they explain it is like, if you have a photon spinning over here, and it's entangled, and you alter its spin in some direction, the photon that it's entangled with, its spin is going to alter in some way. Not necessarily the same way.
But like the space between these two photons?
Oh, that's irrelevant. That's irrelevant.
What the fuck?
The space, that's like why Einstein hated quantum entanglement, is space is literally irrelevant.
So is time irrelevant too? Because space and time, there's a correlation.
Well, space-time, so that's I'm going to take a little side tangent for this. People need to stop thinking of space and time. It's called space. Like, have you ever heard the term space-time?
Yeah, I read it in A Brief History of Time by Stephen Hawking, how he kind of explained how it's one combined thing.
So, yeah, think about it like space is the fabric, time is our description of things that happen to that fabric.
Okay.
Like... It's too, like, okay, when we talk about space, we talk about the stage. When we talk about time, we talk about we're talking about changes in the stage. Okay. It's not, they're not fundamentally different things. They're both descriptors of the same thing. It's just depending on what part you're looking at. Are you looking at what alterations are happening and, like, how they're occurring? And is, like, you know, are you looking for... basically, time is the warping of space, to a certain degree.
Time is the warping of space, okay.
Like, or I guess you could kind of think of it that way. Like, people think of time, like I said, people think of time as a separate thing, but it's really just what's happening to space, and we identify it as time.
Because, like you said in the last podcast, it goes back to change, and that impermanence.
Yeah, exactly.
Always constant.
Exactly, and like like experiments like this are showing us that time might be somewhat irrelevant. So, like, without going through a painful explanation, what ended up happening is they used particles in this that were linked through, like, a quantum entanglement process. And they sent them through different detectors. And one of the, like, basically what ended up happening with the detectors is that they figured out that, like, with how they were reading the information, technically speaking, you could influence the behavior of how an electron appears on this screen. So, like, think about this. Just pathways. Or the photon goes through here. It's going to hit this screen first, right?
The detector 0.
Yeah, exactly.
Okay.
What they found is influencing everything on the... influence of the information at, like, the last detector, detector 4... they were able to influence something that already happened. Like,
so time was irrelevant as well.
Like, that's, yeah, basically, like, think about it. So the photon hits here first, and then it goes off through this entire processes of splits. And you're functioning at the speed of light, which is a finite thing. So it's going to take time to cross these distances. And if these distances are greater than this distance, the photon will reach here first. When it goes through all these series of detectors, basically what they would do was strategically split the beams such that hopefully, basically the universe wouldn't understand that we were trying to detect the information. And we found that all the way down the stream of particle splitting, if we measured a particle, after the first particle had hit the original detector, that the state of the particle observed later influenced the state of the particle detected earlier. Backwards.
Wow.
To a certain degree, potentially backwards in time.
But how were they able to detect it if it already happened?
Well, I mean, so that's the thing is, photon hits here.
Uh-huh.
There's a detector. An observation is made. Data is produced on that photon.
Okay.
Photons fly through this series of crap that they constructed as beam splitters and basically a maze of the light path to confuse the universe, and is detected after that. That detection ends up influencing that read.
Wow.
I'm not fully doing this experiment justice, but basically they would observe, like, by splitting the beams, what they were trying to do was intentionally observe the effects of an entangled particle after its entangled partner had already been detected. And they found that the entangled particle, the entangled particles can influence each other seemingly backwards and forwards in time if you go by...
Because time and space are both irrelevant. So it doesn't matter. Distance doesn't matter. So space between the two and time doesn't matter.
Well, that's not to say... Well, like I said, science is a consensus, not an authoritative statement. What more so this implies is, in terms of information may potentially be able to travel forwards and backwards in time. Like, people we don't even know how, to a certain degree, but what we do now may be influencing things that probably not like centuries before, but like in this experiment, like it's a matter of like microseconds. But it's still
okay.
I mean, like,
but it's still time.
Exactly.
Wow.
Yeah.
It just doesn't add up. And you said that's the same. That would pretty much be the same answer. If you could explain that, then you win all the awards in physics.
If you can answer why they got this result, you will be famous.
Right.
Like, everyone will want to hire you. Yeah.
Goals.
Yeah, like, and that's the thing that, like, that's, I guess, what really informs my perspective on life is that, like, everything we use to define our reality, literally everything we use to define our fucking reality, well, the more we learn, the more we find it's fluid.
Uh-huh.
Like, so people want to live their lives according to these, like, binary constructions of I've got to believe this or that, do this or that. I've got to so many ways. I could give so many examples, but the nature of our reality is something that is so mind-bogglingly fucking crazy. Anything is possible, and that's the thing I like. When people tell me they can't do something, I'm just like, no, you can't right now because you don't believe you can. We live in a reality where, like I said, hypothetically, and like I said, the likeliness is not necessarily great, but hypothetically, I could, between steps, just walking my dog, be transported to a whole nother galaxy, come back, and just no one would notice. It could happen so quickly, no one would even notice. Because it would be almost the time it takes for my foot to move 3 inches.
Right.
Or even less.
And maybe whenever you're dreaming, who knows? Well,
that's the reason all this stuff pissed off Einstein. Is
it's so abstract. It is so abstract and just so mind-boggling that I could see that.
You're trying to create, so, like I said, the concept, this stuff like this kind of breaks down the concept of locality. Because, not just, to a certain degree, really, the butterfly effect, the whole, a butterfly flapping its wings here can influence things there, I
think about that all the time.
Yeah, so take that to a universal scale.
Right.
Things that you do every day in your life may be influencing untold events in the universe. And you would never know. Because you're not fucking out there.
Right.
Because to us, we have locality to our perception of the world. We see everything as existing in a finite space in order, that's the way our brains have evolved to be able to deal with the world into which we were born. Is, it's beneficial to be that there's something over there, okay, that thing has claws, it's moving this way, that's in that specific spot. It's not it's not like these things are necessarily wrong. It's just it turns out they're incomplete pictures of reality.
Okay.
Our senses don't tell us the full nature of everything that's happening. Because, we can't see with our eyes individual electrons, all this crazy stuff.
So do you think the way to figure this out is to look into nature, maybe within animals, or?
Well, I think, because answers to these kind of questions are, it's hard, because we have classical physics, which are Newton's equations that are used to describe the macroscopic world, what we see with our eyes. And the rules for those seem to work pretty well. Until we go down to the quantum scale. At which point every single one of those equations, except for a very select few under very specific specific conditions, all break down and fail to describe the reality you see. Because in Newtonian physics, if I throw an object between here and here, I can describe the trajectory with a simple calculus equation.
Right.
Because it's going to occupy describable finite locations along that path. Quantum mechanics, you don't have that luxury. Because, at the fundamental nature of things, one of the fundamental particles that makes up our existence is this thing called a gluon. And it exists in what's called the gluon field.
Gluon.
Yes. So a lot of people like to think about particles as, they're individual bundles of stuff in space. And they're all, not really fully connected. They're just separate entities that all happen to be of the same kind.
Right.
There's a reason that they're all of the same kind. They're not separate entities. What they are is, So in space, like, there is what's called a photon field. There is an electron field, a proton field. Like, there's a field that pervades all of the universe for each of these types of fundamental particles. And what we observe as particles are excitations in those fundamental fields. So they're all actually part of one singular field. They're just excitations at different local points in that field. So, oh shit, I forgot where I was going.
The gluons?
Oh yeah, so gluons, like all the other fundamental particles, there's a gluon field.
Okay.
And like,
is this like kind of playing to like with neutrinos?
Well, neutrino, like, yet again, neutrino field. There's a neutrino field, like, somewhat. Neutrinos are their own mind fuck.
Really?
Yeah. Like, the neutrinos are in a category all their own, and they're kind of crazy.
Extremely elusive, I know that. That's about all I know about them.
The story of, have you ever, like, looked into the story of how they figured out how to detect them?
I don't think so.
It took 60 years, I'm pretty sure. Or it might not have taken 60 years, but it took several decades. What they had to do, because detecting neutrinos are literally everywhere. Like, neutrinos are passing through our bodies right now having this conversation, as well as literally everything around us.
Right.
We are bombarded by neutrinos. The thing...
Don't they have to actually catch these? I don't know if this is catching them or detecting them, but don't they have to fill up like almost like coal mines with some kind of liquid?
Well, so yeah, what they did is they built this... one of the biggest problems is neutrinos, their signal for our instruments. Now, mind you, there may be sets of instruments we've just never even thought of or discovered that are great, and it's like, oh god, we get all these neutrinos with these. But for our methodologies that we've used so far, there's so much interference from other particles anytime we're, like, say, at ground level, that we can't get a good read. So what they did is they built this basically like this vat full of, yeah, like you said, it's like a liquid that's specifically designed to have particular aspects to it that it can catch/detect neutrinos that pass through it. And the only way that they could get it to where they literally they had to bury this inside of a fucking mountain in Japan.
Wow. And
it took decades. Yeah.
That's crazy.
Like, and the crazier part is, like, millions of neutrinos pass through every square inch of us every second of every day, and they're that goddamn hard to detect.
It's almost like God. It's almost like neutrino, like God's working through neutrinos. I don't know.
Well, no, but, like, for real, it's like, the fuck?
Well, it makes you think about, like, how many things are at play that we can't even, like, perceive. Well, our consciousness, it's not even entering our consciousness, but it's still affecting us. Like, what effect are these neutrinos playing on us?
Well, and so, like, this is kind of what I was getting into in the gluon field is, like, so think about it. I'm going to borrow again, and I'm going to use these napkins this time. So
save the paper.
Yeah. So think about, like, the gluon field is this weird, rough, like, piece of globs that kind of float nebulously here and there.
Okay.
Gluon, so think about the gluon field are little bundles of space on which gluons can exist. So, like, gluons will pop into existence and out of existence. I'm surprised you just kind of accepted that one, but thank you.
Well, no, if you would have told me that, like, at the beginning of this podcast, I would have been like, holy shit. But now I'm like, anything's possible, man.
Well, yeah, like, really, it is. So, like, and to that point, so, like, these things called gluons, they can only exist within the gluon field. But the thing about the gluon field is it's, like all other fields, constantly in fluctuation. So what'll happen is, so this piece of the gluon field, like this gluon will be sitting here, all happy, all nice, da-da-da-da. Suddenly it just stops existing. Literally, I mean stops existing.
Damn.
Like, basically the flow of energy throughout all of the various atomic, subatomic, whatever fields fluctuates such that that piece of the gluon field, gone. So this gluon will just suddenly appear over here without having made any traceable path, seemingly will just pop out of existence and pop into existence on another piece of the gluon field.
Can you explain that one more time? Wait, what?
Like, you ever play hopscotch as a kid? Or what was the game that was like, the spaces?
You're right.
Where
Hopscotch,
yeah. So think about it like playing hopscotch, but the space underneath you is just disappearing, and you have to jump onto another space to keep existing.
So they're pretty much, are they essentially teleporting?
There's no traceable path that we can determine.
And no patterns either?
Not really, no.
And, and they're pretty much, they have to appear in these different spots so just to stay relevant, just to keep existing?
Yeah, and we can predict to a certain degree fluctuations within the gluon field, like we can predict fluctuations within any field, but at the same time, we're talking about a world where anything can happen. So, like another example, nature is full of this. The more we've come to look at it, nature is full of these things we call virtual particles. Okay. Like space. Like Lawrence Krauss, the famous physicist, has talked about the meaning of nothing. Because when people talk about empty space, they're like, oh, it's just nothing. But it turns out there's a lot that happens in the space that we call nothing. Okay. Little tiny particles are constantly popping in and out of existence. It's insane. It's absolutely insane to think about. But empty space is literally filled with little pieces of this and that just popping in and out of reality.
Is that dark matter, or is that just gluons and neutrinos?
That is everything. That is everything. Empty space is full of things, honestly, say, for the most part, things smaller than an electron, we'll say. But say for there's certain there's this like I said, these things called virtual particles, which are basically, if you want to think about it overly simplified, and any of your friends that end up watching this are super science people may already have killed me by now for fucking up so much. I hope I don't get stabbed in my sleep, but there are certain types of particles that, like I said, called virtual particles. So an electron has... two electrons have some sort of interaction. There are times where a little particle, bundle of energy, will exist literally just long enough to make that interaction possible.
And then it'll just disappear into nothingness, or disappear to somewhere else that we are unsure of.
Could be either.
Both are possible. Wow.
Well, because that's the thing we always have to ask ourselves, because there's the fundamental concept of our universe, matter is neither created nor destroyed, everything is in a constant state of interconversion between itself, whatever. That's a really big question in physics, is these theoretical particles that move so fast and are of such reactive energy, or just for whatever reason aren't they don't exist for very long. Their energy dissipates, disperses, whatever. The question is it that say in the case of a gluon, did that energy dissipate and then get redistributed over here? Or did that gluon just disappear and another one popped up? It's
kind of the same thing we were talking about with teleportation. Is that the same? Is it really the same thing? Is it the same you, or just the clone of you? And how is that even detectable? There's no way to know if that gluon, there's no way we could put a tracker on that gluon that's going to appear here and then reappear here.
Well, and that's kind of one of the big things about all of this, is that it's I was saying, everything really what you see as two electrons is not necessarily two separate things, but two excitations of the same thing. Two excitations of the same thing in a different spot. So think about this paper towel is the electron field. What we would classically think of in like traditional physics as like two electrons being like two separate pieces, as though, you know, this is one electron, this is one electron. No, this is the electron field. Over here, this elevated energy area here, this is an electron, and then this over here is an elevated energy area we perceive as another electron. It's not two separate things necessarily as much as two different excitations of the same object.
Okay, that makes sense.
Yeah.
I'm just so lost for words. I don't even it's just...
Dude, welcome to physics, man. Like, the more you dig, the more you're just like, how do any people understand this? Like, because like I said, dude, I've probably butchered so much by now. And, like, some of this stuff I was, like, literally just looking up 2 days ago.
Right.
Like, it's...
And also, you never know how much you don't know.
Exactly. So. Like, that's another big thing. Like...
Holy shit, dude. Oh, you know what this is? This is really giving me an open mind and considering the possibility of time travel, but more than anything, teleportation. Like, I think it's extremely plausible, like, based on everything you've said.
Oh, it's very plausible. It's very plausible, but, like, the ultimate question, it's with all of this technology is it going to work the way we envision it? Is it physically possible in our universe to work the way we envision it? Because, like, teleportation, for example, there may be certain fundamental aspects of our physiology and the laws of physics in our universe that make it impossible. Like, you're ultimately always just going to end up with a copy of the person and not the real person.
Right.
Because, like, one of the biggest things that they've tried to work on in getting teleportation to work is oftentimes in the quantum world, like, when you read the information on a particle, you destroy it.
Okay.
Yeah, so, like, the question is...
So there's no way to tell if it's the same particle if you're destroying it whenever you're reading it.
Yeah, like, is that information off of the particle, is that the person? Or was that information connected to that particle, the person? Because the information, whatever you put it on, if you put it on a blank slate, will produce the same thing. Like I said, you know, a lot of it, like you asked about memory, you know, like in terms of when we were talking about teleportation, like, could you test them by memory? And the thing is, like I said, to a certain degree, like, all of that is the physical structure of your brain. So whether or not it's the same thing, if you reproduce that information, you'll get a carbon copy. But the question is the information what makes that person up? Is that information going to carry their consciousness between point A and point B?
What determines?
Or are they destroyed? Yeah, exactly. Like,
and then recreated.
Yeah.
You're right, there's no way to tell.
No.
Because if they have the same exact memories, then they're going to believe they are the same person, but even they won't know if they're the same person.
Yeah.
I guess if everything is exactly identical on an ethical and moral like standpoint, is humanity even going to care?
That's another question.
Like, is the convenience of being able to, and the luxury of being able to teleport worth the possibility of you not being you?
Forever.
Yeah.
Like, think about that. Like, if certain theories are right, you get erased at the quantum level and recreated. I mean, like, at the most fundamental level, the information that makes you up when it's read is destroyed. At the most basic levels of your existence, you are literally ripped apart and taken away from reality.
And then just 3D printed somewhere else.
Yeah, and whether or not that's you is basically one of the hot topics in science right now, in terms of, like,
holy shit,
talking about, like, just kind of like fun science.
So are they able to determine this final destination whenever if they're going to follow through with like a teleportation device? Are they able to get you from point A to point B correctly?
Over small distances right now, yes.
Okay. So obviously we're just going to keep expanding upon that.
Yeah.
Upon that base. But they're actually able to recreate or the same particle or whatever, or recreate it from point A to point B over a short distance.
Yes.
So the end goal is to where distance is irrelevant, to where space is irrelevant.
Yes.
Okay. Wow.
Yeah.
And then would building off that, then goal would also be for time and space, so time space to be irrelevant.
Well, that's the other thing, like, people don't really comprehend about time, and why I made a big deal about saying, like, space and time are kind of really the same thing. Time, realistically, is just a measure of how quickly you're moving through space. Like, basically, the closer you get to the speed of light, the faster you move in time. Right. So, like one way to put it is, it's a metaphor Stephen Hawking uses. If you ran a train around the Earth near the speed of light, everyone on the train, and you did it for like 2 years, everyone on the train would have aged probably about 2 years, maybe. Everyone outside of that train, potentially hundreds of years may have gone by.
Really?
Yeah. The closer you get to the speed of light, the faster you move through time. And then there's the question in terms of traveling backwards in time, because some people think faster than light travel isn't possible because it violates certain principles in physics. But at the same time, that, like I said, science is a constant series of changes. So we could always end up being wrong.
That can be disproved anytime.
Exactly. And on top of that, people have speculated, so if traveling super fast at the speed of light puts you forward in time, will traveling faster than the speed of light put you backwards in time?
So you said moving faster than the speed of light put you backwards in time?
Yeah.
Okay.
Like, that's...
If assuming moving faster than light is possible.
Yes. And that's like a very big topic of debate among scientists.
Okay.
Because, like, for example, like, people say light is the fastest moving thing in the universe, and that is technically not true. Space itself is actually the fastest moving thing. Gravity is a force stronger than light, and gravity is a function of density of matter. So the power of gravity, or the power of density of matter via gravity, is actually a stronger and more rapid force than light, which is why like beams of light, stars, get sucked into black holes.
Okay.
Like if you put a beam of light close enough to a black hole to where something would get sucked in, even the beam of light would get sucked in.
Right.
Like, it's thought to escape a black hole, you actually would have to travel faster than light to escape the gravitational pull, because it's been shown.
But how much faster than light?
Well, that's a whole other question.
Probably a lot.
Yeah. Well, like, it's the thing is, like, a black hole, if a black hole can pull in light, that means that the space, like, gravity is a force that acts on space. And essentially, like, space can actually move faster than light. Mm-hmm. Space itself can move faster than light. But nothing else in the universe, really.
That gives us hope that we can move a lot quicker. But how does space itself move quicker than light? How does space move? Does it move at like an infinite speed, like assuming like teleportation?
Well, that's the whole concept of the Big Bang. Space is actually itself expanding. Like, the idea of the Big Bang is like, we're living in a blast zone. We basically, if the Big Bang is true and there's a lot of evidence right now that either it's somewhat of an incomplete picture or we may start moving towards different theories in the next decade or so. But for now, it's still widely accepted, or at least versions of it are widely accepted, especially ever since they discovered gravitational waves, like officially detected gravitational waves. Where was I going? Sorry.
Big Bang, to see if it's still plausible.
Well, okay, so like I said, if that's true, we live in a fucking mushroom cloud. That is what we live in, is the explosion cloud of the Big Bang, and it's just expanding and expanding and expanding. So think
at a constant rate.
Yeah, exactly. So think about it. We are an object. If we're an object within the mushroom cloud, the mushroom cloud is growing around us. So the actual space we have to occupy is growing around us, and the universe is accelerating faster and faster. Like, its expansion is... That was one of the freaky things we observed when we started really noticing the rate at which objects in the universe were moving away from us. It's called, like, the universal redshift. It's, like, based on the Doppler effect. The Doppler effect is, like... You ever hear of weather, like the Doppler radar?
Yeah.
Yeah, well, so the Doppler effect is just basically a simple concept. Things that are moving towards you, the light is going to be more blue, because as it's getting close to you, the wave is getting bunched up. Or, I probably fucked that up. The point is, due to the way the wave, like the sound wave or whatever wave you're observing, light wave, whatever, moves towards and away from you, when it's getting closer, you're going to observe what's called a blue shift, because the way the wave frequency expands or contracts throughout space as it gets close to an object. When it's moving away from an object, you get what's called a redshift. And we noticed when we looked up in the sky for the first time with really advanced telescopes, well, not even really, but like starting to get advanced telescopes, we noticed everything we saw in the sky for the most part was redshifted, as though it was moving away from us, as though it was expanding.
Oh, wow.
Yeah. So there's actually like...
This isn't any correlation to the Roy G. Biv. Is it like the I think that's a temperature thing, like dependent on colors.
I do not remember what Roy G. Biv stands for.
It's like red, orange, yellow, and then on the other side of the spectrum, like Biv is blue.
Red, orange, yellow, green, blue, indigo, violet.
That's probably right. I'm not sure about the indigo, but that's probably right.
Well, yeah,
I don't
like
know what else I would be.
all color really is our brain's way of interpreting, like what we see as color is just our brain's way of interpreting different light frequencies.
Right.
And what a different frequency is basically, it's really simple. Is the wave bunched up? Like, is it like this? Is there space between the wave? Is it really close? Like, is it really far? Like, that's what we see as color, basically. And we use that knowledge of frequencies and how they behave in relation to an object to extrapolate that data, like the idea that the universe is moving away from us. And they've actually speculated, like some scientists say, like, we really need to start trying to move out towards the stars as soon as possible because they're literally growing away from us. And there's speculated that there's going to be a certain point at which the acceleration of the universe becomes so great that we'll never be able to reach certain objects because they're expanding away from us so much faster than we could ever hope to reach.
I'd assume that's already happened.
Probably.
At least for some stars. Not necessarily everything, but wow.
Yeah. Well, I mean, another way to think about it, like, to give you an example of like how our universe, how space moves faster than light. Our universe is, I think, like 14 billion years old, we estimate.
Mm-hmm.
Our universe is like 98.6 billion or something light years across. If our universe were strictly expanding at the speed of light, it would only have probably a diameter of either 13.8 or like, well, no, since it's expanding out in all directions, it would probably have a diameter of about 27.6 billion, or 27.6 billion light years across. Because, okay, light years, just to be clear, that's a measurement of distance.
Yeah.
Like, that's not time. Like, when scientists talk about light year, that is the amount of distance light travels in a year. And the main reason we use it is it's good for describing really big distances.
Right.
So
it is deceiving, though, the name.
Yeah.
It has time in the name. So.
Yeah. But like I said, so, if the universe were just moving at the speed of light, our universe would be about a third the size that it is right now. Or actually, let's see, so about a fourth the size it is right now.
Right.
Like a little less than a fourth. But yeah, I mean, so nothing about our experience of the world basically is true to the nature of our reality.
Dude, that's so crazy too, because I think society has kind of taken on a paradigm, especially in recent years with like the internet and everything. Like, I think in like artificial intelligence on the way, and all this incredible exponential growth in technology. I think we've kind of taken on a paradigm that we know everything, and that could not be further from the truth. Especially when you're talking about physics. This is insane.
So, and let me bring this into our own anatomy. So...
Oh, God.
Okay, I'm going to pull this one up on the computer if we don't mind, so I don't make a fool of myself. But, small nucleolar RNA and small nucleolar protein. Oh, is it okay if I run to the bathroom again?
Yeah, totally.
Okay, I'll be right back. Oh, those were some good body cracks.
This water is going straight through us.
Oh, God.
Wow. I don't know about anybody listening, but my mind is absolutely blown. Like, episode number 45, mine 44, Joel was on the other one as well, right before this. And I can honestly say I don't think he's blown my mind as much as any guest yet. This is insane. It makes you, it's good to have people around you like this to make you question your beliefs in life, because wow, it's just, I don't know, I guess you can kind of live with the ideology that you know everything, that you have it all figured out, but in reality, when you hear something like this, it's just so mind-boggling that I am so lost for words right now. It's ridiculous. Wow, yeah. Good guy, though. Yeah, you may not have guessed this at all, but the way I met him was through jiu-jitsu practice, and he's actually training to be an MMA fighter. That's his goal right now, and I believe he could do it. He's great. He'd put me on my ass whenever we would roll. Wow. Yeah, if you guys are interested in any of this at all, some things I've written down just for my own personal research. Quantum entanglement, which he said Einstein was very just annoyed by this theory because of how, not irrational, but how difficult it is and just to explain, and how little sense it makes. And then the quantum eraser and the double slit experiment. These are all things we can look into. I know I'm definitely going to do some research. I would like to have him on again. And
I have 3 hamburgers back if you guys want any.
You said 3 hamburgers?
Yep.
I think I'm gonna eat because I'm fasting right now, and I fasted last night. And I don't think I took in my full calorie intake, and I can kind of feel a lack of focus. But yeah, we'll be up in a little bit. He's down. He's in the bathroom right now. Yeah, this is I feel like this is something you definitely need to look into yourself before talking about it. I'm gonna snag some of these grapes as well. You know when you haven't eaten anything for like a fair amount of time? I mean, I haven't eaten like a few hours, but and then that first thing that touches your mouth, like your taste buds are just hypersensitive to. It's like a really good feeling. I love it. These grapes taste like extra sweet. Joel, I decided I'm breaking the fast tonight. Because especially, I don't know if you can tell in the beginning of the podcast, but like, my, because I've been going like fasting on, fasting off kind of deal. Fast on, fast off. But especially because I the way I've always eaten is that I eat like literally all day long, like most Americans, and honestly I'm very guilty of gluttony, and is what it is. But yeah, I think I can feel a lack of focus, especially in the beginning of this podcast, and then part of it was probably just like how like intangible and how hard this is to like wrap my brain around.
Oh, yeah. Dude, I still have no fucking clue about most of this shit.
I don't know what you mean, no. And how could you? How could you?
Like, I mean, like, I know a guy who got a degree from Rolla in, like, nuclear physics. And he's like, yeah, half the days I'd go to class, my teachers are like, so here's this thing that happens. We have no idea why. If you can figure out why, you're probably going to get a Nobel Prize. So here you go. And people will be like, is there a chance that this is wrong? Absolutely. Like,
so open to interpretation. That's insane.
Yeah. Well, I mean, like, and that's the thing is, like, if you want to be a good scientist, or if you want to, in my opinion, be good at analyzing anything, you have to be open to the concept that your frame of analysis can always be wrong.
That's an effective scientist. I agree.
Like, yeah.
And there are no ties with your own personality within there, because that's just... That's misleading.
Yeah.
Actually, dude, you would appreciate it on this. This is absolutely insane, and I didn't realize this until like somewhat recent years. But so I went to a it was a Lutheran school. It's called Emmanuel Lutheran. I don't know if you've ever heard of it. It's in St. Charles, Missouri. First of all, fuck that place. Fuck that place for a multiple. One, it was really strict, and I could get into all that. But dude, no joke. This school, like, because since they're a private school, they can teach whatever they decide to teach. No joke, they did not teach us science. 1st to 6th grade, man, I did not learn science.
What?
I swear to God.
What?
I was never taught science, and I switched to a public school in 7th grade. I started learning science from then on, and like I struggled in science at first. Like now it's probably my favorite subject, honestly. That and history are probably the most two most interesting. But yeah, I was never taught science.
See, like, we would have science classes, but we'd have textbooks from, like, the 1980s that would talk about how by the 1990s, and I shit you not, I had textbooks in, like, 5th grade science that would talk about how, like, by the 90s we were gonna, in, like, the 2000s, we were gonna, like, have moon colonies. Like, I mean, like, full-on, like, cities on the moon and shit. And I'm just like... Yeah, we totally, like, I was fucking, like, 11 or whatever. I'm like, yeah, we totally don't have that shit right now. Like, this, I'm teacher, I think they're wrong here.
Yeah, really?
Like...
That's really, that's insane.
Like, yeah.
I think that's so funny with moon travel. Like, we haven't even been back to the moon since, like, what? I don't even know the last time.
Well, yeah, because, like, Neil deGrasse Tyson explained it really well. Like, going to the moon, like, moon missions... are expensive as shit, and we didn't really ultimately go there for like all the ideology, science. It was the fucking Cold War. We wanted to get to the moon before Russia.
Right.
We wanted to do everything before Russia because any time we lost was a potential strategic advantage we gave up.
Which is another reason for why artificial intelligence. Not to get off topic too much, but that is why artificial intelligence is going to be inevitable because it's an arms race because we're competing with all these different countries.
Yeah.
And that's the scariest fucking part about it. But yeah, anyway, continue.
Well, oh fuck, what was I saying?
You said that we originally went because of the Cold War to the moon.
Yeah. I mean, if you look at it, our moon mission stopped once the Russians stopped giving a shit about going to the moon. And it's a really funny coincidence. So now, sorry.
What a weird motive.
Politics.
Yeah.
Well, but like nowadays, like, what's the drive to go to the moon? Like, we're more focused on other things. We want to go to Mars. We want to explore, hopefully, outside of our solar system. We want to do all these other things, which is why, like, nowadays, when people are like, we're going, like, some politicians will be like, why haven't we gone to the moon? I'm like, because there's not that much to be accomplished right now from going to the moon. Otherwise, they would have fucking plans for it.
Exactly.
Like, all this shit is astronomically expensive. So NASA can't just be like, all right, we're going to work on Mars colonization and go to the moon and have the International Space Station and do X, Y, and Z things. Because, like, one of their satellites costs a couple million to a couple $100 million to a couple $1 billion to do. And, like, the cost of keeping people alive in space, the cost of having all the infrastructure to make that even fucking possible is astronomically expensive. Astronomically expensive.
So how do we begin to fund that? How would you... I'm convinced if we could get enough people curious, we could almost work in like an interdependent way. And I know this kind of sounds like we were talking about earlier, like a form of like fascism or something. But I don't know. I think right now it might not be like a culturally accepted norm, but if we could get like a majority of society behind like overall end goal of getting us to be a multi-planet species, then maybe we could like make like a space tax or something like that, like to where we're actually funding this stuff for NASA.
Well, so like there's this one guy who... Have you ever heard of the app Duolingo?
No.
It's the... You ever done like a CAPTCHA, like a thing where you're on a website and it's like, do this thing, like retype this thing in this box here to prove you're not a robot, basically.
Okay. Yeah.
That's what's called a CAPTCHA. And the guy who invented that, or there's one guy who invented that specifically. And at first, one day he realized after he invented it, he's like, I'm making people waste like, depending on how much they use the internet, potentially hours of their lives.
Like collectively?
Collectively, just like typing random bullshit. Like, you know, because like every individual time you do it, it's like a couple seconds to a minute.
And it's annoying, man.
But, like compound that over your entire life, especially in the modern age where it's not looking like you're just going to use the internet less, like, you are actually taking up a decent amount of time in someone's life just to type in bullshit to prove they're not a fucking robot.
Yeah.
And it serves no purpose. So what he started doing is like... Nowadays, if you'll notice, like, the way they do captures, it's like image recognition, or like... Have you had it where it'll be like, pick like the panel in this photo that has a sign in it, or like shit like that. Mm-hmm. That was actually intentional, and yes, it's a more advanced way of filtering out robots, but also that actually helps to serve as data for image recognition, like that informs image recognition software, all sorts of all of this. Like
he created something that led to something else?
Well, he created something, realized that it was useful, but didn't ultimately serve everyone who used it. Like, it served the websites that used it, not the users of the website, because to them, it's just a fucking waste of time.
Right.
Like, so now they're actually at least saying, like, well, those 10 seconds went to, like, something, you know? It's not completely wasted time. Off of this, he came up with this idea for this app called Duolingo, which is basically, like, it's a free tool to learn languages. There are programs for several languages in it, and it's been proven to be about as effective as Rosetta Stone. And what it is so it teaches you language. It uses your input to help translate phrases of books. So you're learning a language while simultaneously you're also, it's not just like arbitrarily like translating sentences. The sentences you translate in Duolingo are actually used to help create construction, or like basically they're helped to translate and digitize books.
Oh, wow.
And so and like where he kind of went with this, why I mentioned why you'd heard of him and like, you know, getting people cohesive, he actually like, he kind of studied big projects in history, the Manhattan Project, the project to get to the moon, other large undertakings. About 100,000 people working on one goal is what's made this stuff happen. So his concept, his vision was, what if I can create this app that's able to be dispersed among millions of people, all working towards this goal of digitizing human knowledge, translating and digitizing human knowledge.
So it's completely shared and it's just in the ether, accessible to anybody.
Yeah. And like the crazy...
Oh, I love that.
Like, so basically, he is pushing... Unbeknownst to, because a lot of people who download Duolingo don't fully know the backstory. They just know it's a free language app.
Right.
Like, they're unknowingly helping to do all this shit to digitize all these books and help to translate and better communicate all human knowledge. Like, he has...
Wow.
Like, basically, he is... by creating an app that teaches you how to write or how to understand, read, and write new languages for free... He has gotten millions of people to sign on to help him digitize all of these books in all of these different languages, from fucking Spanish, Italian, French, German, Portuguese, Korean, I think Chinese. They're always adding new languages. Like, and it's not just like English. There are versions of it for like Polish people trying to learn things. The longer it's existed, the more it's expanded.
Right. It's only improving. It can only get better.
Yeah, exactly.
It's like a YouTube video. It can only get more views. It can't go down. Okay.
Yeah, and like... So that's kind of the thing is, I think in terms of getting some of the bigger projects of humanity done, is going to come through technologies like that where people don't even realize they're fully doing it.
Yes. It's virtually creating a mastermind amongst most humans.
Yeah.
There are tissues in here.
Oh, wonderful.
Oh, delightful. Oh, they have the lotion too.
Dude, that's actually pretty handy. I didn't even think about it. I just put it on here because everybody was tapping this desk and like you could like hear the vibrations in there. Actually, on that same topic, my buddy came on the other day and he said there's a Nikola Tesla quote that if you want to understand the universe, think of it in, I think it's energy, frequency, and vibration. And I just found that quote extremely fascinating.
Well, so, like I said, you know, like, so the electron field, for example, it's there everywhere constantly. What's happening in it, and therefore how it's behaving and how it's acting on the environment around it, is determined by those three things you just described. Energy, frequency, vibration.
So those are the forces acting upon it?
Not the forces necessarily, just some of its most important properties. How much energy is put in that specific spot, at what frequency is that energy vibrating, and that will tell you a lot of what you need to know.
Okay.
Like, yeah.
Yeah, it's kind of interesting.
Oh, yeah. I forgot. I was going to make the whole mindfucky thing come full circle and bring it into human anatomy.
Oh, yeah, absolutely.
I just remembered that.
Ooh, no internet connection.
You're not cool enough for the internet, apparently. So.
No love. There we go. Cool.
All right. So, you know, okay, nucleol. So there's this thing in our DNA. So I was kind of talking about earlier how, like, you know, at the fundamental levels our universe defies like all of our descriptions. So small nucleolar RNAs are like, okay, we can just read the Wikipedia page here. They guide chemical modifications of other RNAs, mainly ribosomal RNAs, transfer. Basically, like, what you need to understand is they're very important in the regulation of, through modifying, of basically the way your genes are read. Like, small nucleolar RNAs, they're... So you have DNA.
Right.
DNA is like the raw code. So think about it, DNA is the library. RNA is the librarian. RNA is the person that is able to access and read all of that information and relay it in a way that is intelligible. That's what RNA does. Protein is like the active compound that you get from synthesizing information in the DNA. Like, the way it traditionally goes is DNA is read by RNA to create protein. Okay. Or sometimes DNA is read, produces RNA, and the RNA just acts on its own.
Okay.
And in this case, this is an RNA, like, that helps to modify other RNAs. Like, basically, it regulates what kind of protein is going to get produced to a certain degree. Like, the biggest thing about, though, why this is, let's see, there's a nifty chart. I'm going to borrow this for a second. But the thing is, so it has a protein counterpart called small nucleolar protein.
The small nucleolar
The small
RNA.
nucleolar RNA has a protein counterpart that is small nucleolar protein. And basically the two function in this modification role of altering genes, or of altering RNA once it's read the DNA. Like, the most important thing about it, like, I could tell you, you could have a whole fucking class on just like one type of RNA. That's oftentimes how genetic classes go. Is though, like, you can spend one whole class or multiple days of classes on one single thing because it's just so goddamn complex and interrelated. But like I said, it has a protein counterpart, small nucleolar RNA. It is like, so the small nucleolar RNA associates with these proteins to help carry out those modifications I talked about. To produce small nucleolar proteins, you need small nucleolar RNA.
Okay.
To produce small
It's dependent on that.
To produce small nucleolar RNA, you need small nucleolar protein.
Wait, say it all again, really.
To create small nucleolar protein, you need small nucleolar RNA.
And vice versa?
Yes.
So where the fuck does any of it come from?
No, that's my whole point. That's my whole point, is like, it literally, because this is a fundamental mechanism to how our genetic code gets read and modified. Okay. This is like, you learn this stuff in Genetics 101.
Okay.
It is, like I said, fundamental to our existence, basically. We don't know how the fuck it happened, because, to your point, if you need one to make the other, and you need the other to make that one, where the fuck does it start? Like, where?
Yeah.
Like,
do you think there's a possible, like, third party that is dependent upon the two, or like the two are dependent on that third variable, or?
Well, like, this is another one of those things. If you could answer this, Nobel Prize.
Oh my
like,
goodness.
Instantly, like, you answer this question, Genetics moves at a really high pace, so maybe this, like, you know, because I learned about this a couple of years ago in school, so it may have an answer now, but, like, the thing is, when I was in school, there was no answer, and anyone who proposed a viable answer that actually seemed to hold experimentally true is probably very, very famous right now, if they exist. Because, like, the possibilities are endless. Is it like some kind of protein worked its way into our DNA? Such, like, you know, it was introduced foreignly? Did we capture some foreign genetic? Like, what the possibilities for how we came to each genetic the possibilities for how we came to everything in our genetic system are endless. That's why genetics is such, like, genetics is the particle physics of biology, like, because there are certain types of physics, like, and what I mean when I say that, there are certain types of physics where it's like, you know, basic laws of motion, like Newtonian motion. Like, if I throw, like I said earlier, if I throw a ball, I can describe it. I can describe its trajectory, its motion, very cleanly using well-tested equations.
Right.
But when you get down to particle physics, it's a lot harder to do all of it.
It just seems so random and spontaneous and unpredictable.
And that's exactly what genetics is to the rest of biology. Because it all ultimately works out into these systems we see that, you know, obviously form coherent structures that are viable and function fine. But when you look at the reality that makes that all happen, it's such a goddamn confusing mindfuck that you're just like, where do I start? Like, just even the theories of how our genetic material came to be are endless. Like, have you ever heard of this thing called the tardigrade?
A tardigrade?
Yeah.
No.
Did you watch the most recent season of South Park?
No.
Okay, I actually love it because there have been a lot of papers recently about this animal called the tardigrade. It's like a tiny, tiny, microscopic little thing, and It's also called like a water bear. I mentioned South Park doing a thing, or I mentioned South Park because they had an episode that actually featured them, and in a hilarious way, kind of pointed out like some of the aspects of their biology. Now, mind you, it's South Park, so they took it a little crazy, and the things formed like little societies and civilizations and crazy shit like that happened, which we don't think is possible, but who fucking knows? But, like, these organisms can survive electric shock, flames, the vacuum of space, nuclear explosions, nuclear radiation, literally, like, anything that would kill anything. You can you can throw them out into space. You can dry them out completely for millions of years potentially. And the second they get close to water again, or like favorable conditions,
they're done.
No, alive again.
Wait, what? They go from dead to alive to
They can go into a very deep stasis state.
I thought you were trying to say that water was the one thing that kills them off.
No, well, they're called water bears because they're found often in water.
Okay.
And like also, if you look at little pictures of them, kind of look like little tiny bears.
Wait, just water bears?
Water bears, tardigrades. You can find.
I'm gonna say water bears just because they're.
And that's the tardigrade. Cute little guys.
They kind of look like an amoeba.
Yeah. And they're really simple animals. But like I said, they can survive just about everything that we have been able to figure out. I cannot to put this. Think about this in terms of like, because there's right now a big debate in science. It's actually considered a valid, like, legitimately debated topic whether or not life originated on Earth, or at least the chemistry behind our life originated on Earth, because life, or at least the chemicals associated with life, started appearing in really high abundance that we can detect in sediment layers right after there was a huge bombardment of comets.
Okay.
Like, a bunch of asteroids and comets hit the Earth. It's this giant volcanic, like, hellstorm of lightning and fire where literally chunks of, there are literally flaming balls of rock falling from the sky.
Uh-huh.
And right after that...
So basically, this biological genetic makeup hits the Earth and happens to fall into favorable conditions.
That's kind of the thought. And that hypothesis, that's, like, the idea behind it. Because they've found, like, basic amino acids, which are what are some of the basic building blocks of life, like the chemical building blocks of life.
Uh-huh.
They found on comets and asteroids out in space. Like, just floating out in space.
Really?
Like, these molecules can exist in the vacuum of space because, like, all of our previous logic would have dictated that the conditions in space are such that it would have forced the molecules to break apart into less complex pieces. But lo and behold, they're there. Like, I don't know, like, there was the big experiment, like, a couple of years ago where they, like, had a probe that, like, they basically fired into a comet. Like, it was kind of a big media deal, but, like, one of the big things they learned about that, they've learned from that in experiments like it, is they found in the rocks of these comets and asteroids...
Uh-huh.
pieces of amino acids.
That doesn't add up at all, yeah.
Yeah, and then on top of that, like, tardigrades can survive in space. Like, I don't mean, like, we take them on a spaceship. I mean, like, you put them out in the vacuum of space.
And they're still living out there.
Well, what they do is they go into deep stasis.
Okay.
But, like, that's the thing is... it seems that life and the chemistry of life is a lot more resilient and also, to a certain degree, literally universal than we thought. Like, because before we studied this, we're like, can amino acids even exist off Earth? Like, is the chemical makeup of anything else in the universe possible to lead to this? I mean, it's not like kind of a sense of arrogance, like, oh, this is the only place it could happen. But I mean, just genuinely, like, you want to think that the universe is a big place, so yeah, it's possible, but science is such that it goes by evidence. So until there's evidence, you can't say whether or not it's true. But we've found evidence, like, now that...
or that they're exclusively happening just on Earth.
Yeah, exactly. And now we've started to find evidence that it's not exclusive to Earth.
That's what blows my mind, too, is, like, water's found everywhere, and oxygen, all these things that I thought were only exclusive to Earth are everywhere. They're found everywhere in the solar system.
Well, and like, that's like one thing a lot of scientists have talked about, because there's this thing called the Fermi paradox. It's, simply put, it's the concept that if there are aliens in the universe, like if there's life other than us, where the fuck is it?
Right.
Like with how many planets there are, if there's other life, why don't we see it? And there are many different answers, everything ranging from, like, we can't detect it, to everything, like, basically civilizations destroy themselves before they reach the stage where they can travel throughout the stars. But there's the one that I am most fond of, personally, and this is a personal opinion, because you can make an argument for any of these things. I like to believe, and like I want to clarify, like, this is more of a personal belief than like a fact of science. I don't want, like, people to think that. But, oh god, I was going to say something cool, then I lost it.
Was it more of a personal belief instead of a fact of science?
Oh yeah. To a certain degree, yeah, there might be life out there that's more intelligent than us and just, like, hiding from us, basically. Or, like, so advanced that we can't perceive it.
That's plausible. That's possible.
Well, like Michio Kaku, he's like a world-renowned physicist. If you've ever seen, like, a Japanese guy with white hair on TV talking about physics...
He came to one of my colleges whenever he visited, but I didn't know his significance until... I'm pretty sure. It was a very famous physicist that came to visit my school, and he was Asian. That's all I know.
That would probably be Michio Kaku.
That's crazy.
But, like, he's... like, he talked about it, and I mean, this was years ago, you know, like, he's just like, when we build an 8-lane superhighway next to an ant colony, do we take time to explain anything to the ants? Do the ants...
Oh, wow.
Do you think the ants even have a clue what the fuck is happening next to them?
No. Oh my, wow. What a great just metaphor that's just an explanation.
Yeah. Like...
Yeah. It could be happening right next to us.
Yeah.
So are you familiar with like Alex Jones at all?
Oh god.
Well, he always talks about like interdimensional beings.
Oh yeah.
Actually, kind of sounded like him there first. Interdimensional beings.
It's the goddamn energy vampires. It's the goddamn energy vampires.
Hillary Clinton is running a child. What is it? Just child sex slave out of a pizza company.
Run on children's blood and vampiric blood orgies. But, like, I mean, kind of like the whole, like, oh, he's fucking ridiculous, don't get me wrong. But, like, I don't even know. Just, that's my thing about, like, alien cultures, though, is, like, ones that are more advanced than us. Can we even comprehend them? And the other thing that a lot of physicists point out is, like, our perspective on what life is very limited.
Right.
Very limited, because we've lived in a world where there's one type of life based on carbon in the presence of a lot of water. So when we look for life on other planets, we look for a lot of we look for carbon and water. And it's actually been shown to be chemically possible because of the similarity of chemical structures. Like, why a lot of life is carbon-based is because carbon is a very special atom, because it only has 4 electrons in its outer electron shell, which can hold 8. So it can form 4 chemical bonds with things, which makes it very versatile in how it can create very complicated chain structures, some of which loop in on themselves and have all of these crazy consequences. Silicon can do the same things. So silicon-based life, chemically speaking, is entirely possible. But the thing is, we don't even understand how that would work, because all of our chemical systems are based around carbon. So we understand life chemistry in the context of carbon chemistry. We don't understand life chemistry in the context of silicon chemistry. We don't even know what that would look like. We don't know how to detect for that, because, like...
And that's just one other branch of it.
Yeah, exactly.
Holy shit.
Like...
And in theory, they could be infinite branches.
Yeah.
So indescribable. And unimaginable.
Yeah. There could be beings, for all we fucking know, like the planets that we're like, oh, they're just gassy rocks. There might be organisms made like that basically are just balls of gas, and we don't even like. They're an organism, but just not in a way that we could ever fucking comprehend right now.
Right.
Because we're so like. The way I like to view humanity, and like definitely myself, is I am a very limited being. We are very limited beings. Which is why we should have our eyes wide open to this crazy fucking cosmos around us that's just like someone recently asked me, because like I to a certain degree like I use the word magic, and people are like, oh, you're a man of like, you know, you're like a kind of a science guy, like how do you believe in magic? And I'm like, because magic never went away, we just changed its name. Like the fact that I can tell you that like anything we're not looking at in our universe might literally be everywhere and nowhere at the same time, is that not sound like fucking magic?
Magical.
Like, magic is the feeling I get when I look up at the sky and I realize that, like, the atoms that are in those stars, everything that I ever was, am, or will be, everything that has come before me or will come after me is made of this, literally the same atoms that make up those stars. And I am a piece of them and they are a piece of me. I am literally but a fraction of the universe I inhabit. I am only a piece of it, and I'm a part of it. And that's fucking magic to me.
That is magic.
Like,
that is magic. Wow, you want to end it on that?
sure.
Dude, honestly, you were blowing my mind more than like any of these podcasts. Because like, I've just been at a loss for words, like more than anything on this. And I love it. I absolutely love it.
Well, and like that's the thing. That's why I wish people were more into like, because when people think of science, they think of the boring shit. Like, and honestly, you have to learn the boring shit to even come to start understanding some of this stuff. But once you can get past that, like you go from like, oh god, I'm gonna have to describe. I have to like give the math for how this ball rolls down this slant. And you go from that to like, this is how our entire universe might be one goddamn tiny particle that no one's looking at.
How? Some interconnected particle too.
Yeah.
It's some interconnected particle that I don't even know if we'll ever fully understand it. Maybe that's just not the point. Maybe humanity, like, we're always trying to figure it out, but maybe we're just not meant to fully understand it.
There's this one story, and I think it's Isaac Asimov who wrote it. It's called The Last Question. Have you ever heard of it?
No, I haven't.
So, the story starts off talking about basically how humanity's made this computer that can answer literally any question. It's a learning machine. Like, it's what we comprehend to be what AI will become. Like,
okay.
You know, it's something that has learned, like, it's a machine that can learn, extrapolate, like, draw on information from everywhere, and is able to perform computations at freakishly high rates. And, like I said, can pretty much answer any question. Like, there's this big breakthrough with the machine that they have.
This is only one machine?
It's one machine. And they feed it this one question, and it's, how do I reverse entropy in the universe? Entropy is the natural state we observe in the universe such that things go to a state of order to disorder. Anything in our universe that is ordered will go towards disorder, just because of the way that energy flows in our universe from places of a lot of energy to places to less energy.
Okay.
That's entropy, is the law that...
So it's kind of the same idea with like the climate always trying to find an equilibrium, even though it never will.
That's exactly why that happens. Entropy is the reason that happens.
Okay.
Because energy is constantly flowing from localities of high energy to low energy. And that's why things in our universe don't last forever. So in the story, The Last Question, they ask it, how do you reverse entropy in the universe? And it takes a while, and then like, this is a machine that can answer anything, and it comes back, need to collect more data to answer this question. And the story keeps going through the story of humanity to the point where we become an interplanetary, intergalactic, universal species, to the point where we've become almost so godlike we're just floating consciousnesses existing in the universe. And the question persists, and the answer is always, and basically, more data needs to be gathered to answer this question. And the story ends, basically, with the last human dying. And then the machine finally, like, the universe ending.
Uh-huh.
And this machine finally comes up with its answer. And the universe is reborn from the start.
Holy shit, yeah. Need to collect more data.
Until literally the end of time. And then it literally starts it all over again.
Do you think maybe this is just the 659th time that we've restarted?
Well, I mean, like, that's actually a big thing of, like, Buddhist, like, religious belief and philosophy, and, like, Hindu philosophy, is that the world has been born and died multiple times over. Like, I'm pretty sure in the Hindu cycle of things, like, we're in the 6th iteration of our planet. not of our planet, but of our universe.
How did they come up with that explanation?
I'm not sure quite historically, but I know basically the way that it works out is there's this one God, and whether his eye, like when he opens and closes his eyes, universes are the universe is either created or destroyed.
Okay.
Like basically, I can't remember if it's the God falls asleep and our universe exists, and when he wakes up, it's destroyed and falls back. But some variation of that kind of cycle. Because I think it's like the Brahman or whatever. Like, Hinduism is this interesting religion because it's not... It has many gods, but they're all ultimately iterations of one deity.
Okay, maybe multiple roles in that aspect, or...
To a certain degree, yes.
Okay.
Like, think about it, their god structure is kind of like how I view the universe. Like, their gods are all pieces of one single entity that makes up their, like, ultimate unifying god, force, whatever you want to call it. And that is what kind of determines the whole... Like, basically... The life of that God is what determines the direction of our reality. Whether our universe is created or destroyed, whether anything happens.
Okay.
Yeah.
Wow. Dude, wow, yeah. I would like to, maybe at like a different time, but I would love to hear, like talk like Buddhist philosophy as well. Sure. Yeah, because that's something I've been a lot more, I guess, straying towards as of lately. Like, I just find that, I don't know, I guess less wrong, like we were saying earlier. Just, I don't know, less wrong than Christianity, in my personal opinion.
Well, like, the big thing about Buddhism, when you read the books of Buddhism, that's the difference for me, is like... There are books in the Bible where it's literally some person telling you this is how you're supposed to live and this is what you're supposed to do. Mm-hmm. Like, Buddhism and also Taoism are very much, like...
Open to interpretation?
Yeah, like, well, their kind of point is your interpretation of the world is what creates everything in your world.
Kind of like the ideology, like like everything you see inside yourself is a reflection of the external world?
Yeah. Okay. Well, and like the one of, kind of, I touched on this earlier, like, so, you know, Islam, Christianity, and some of the other major world religions have a very clear-cut and well-defined sense of right versus wrong. Buddhism and Taoism, right and wrong are not necessarily as clearly defined. Because it's not as much about defining things as this or that.
I like that.
Yeah.
I like that a lot.
Like, there's this one of the Tao Te Ching is basically like the Bible of Taoism. It's like the foundational text, and it's just a series of, I think, 80-something poems. Okay. But one of the great, like, it describes a series of things, but it's basically like, the only reason there's dark is because we say there is light. Mm-hmm. Like, but ultimately, light and dark aren't really things. Like, like, right, okay, or I should say, like, you know, right exists because we think things are wrong. Like,
in reality, neither one is even real.
Exactly.
It's just our own judgment.
Right. And like,
right.
Like, no, really, no, I mean, like, really, though, that's the thing, is like, whether something is right or wrong is not inherent to the universe. It's whether or not you decide that. And you can decide that things are neither right nor wrong, but that they just happen. And that's kind of the whole view.
It just is.
Exactly.
Okay.
And that's what philosophies / religions like Buddhism and Taoism encourage, is that not the fact that you should, like, you know, oh, there's all this evil in the world, how do they... everything exists in an attempt to attain an equilibrium and a balance.
Right.
And like people always karma is one of the most misunderstood concepts in Western society, because we'll be like, oh, you know, do this, it's good karma, and like some people start to think like Buddhist enlightenment is achieved by having all this good karma.
Okay.
Karma is often described as think about it as a pond.
Uh-huh.
So the idea, your ultimate goal to achieve enlightenment is to still all of the waves on that pond. Any action you take that is considered good or bad, it's throwing, so a good action is throwing rocks into the pond.
Right.
A bad action is throwing rocks into the pond. If the goal is to still the pond, you're not trying to be good or bad. You're just trying to be.
Yeah.
Because no matter what you do, you're going to disturb that pond. If you define your reality simply as good or bad.
Well, assuming that you throw the rocks.
Well, no. That's what I mean. Is like good karma, bad karma. They are both equal disturbances of that pond that is your mental state, your spiritual state. And the goal is to still yourself to a state of calmness, to a state of evenness, to a state of balance. Such that either you're throwing rocks into the pond in such a way that they balance each other out, or you're throwing no rocks at all.
Okay.
The idea is not to be tilted towards one extreme or the other, but to balance them. Because one of the biggest things I like about those philosophies is Christianity and Islam basically teach you to deny your darker self. They tell you have a darker self and that you're basically going to be in a constant battle your entire life to fight it. And
so, do they kind of say that there is a duality within you, that you have two selves, kind of, one's dark, one's light, almost?
Well, so think about the yin and yang symbol. There's light in the dark and dark in the light.
Right.
And so people always want to think oh, I want to be on one side of the thing. The goal is to be the line between.
Oh, shit, okay.
Yeah.
Wait, yeah. I've noticed, looking into a lot of philosophies, I think balance is a reoccurring theme with virtually everything, almost.
Yeah.
Finding some equilibrium, some threshold.
Well, because, that's what gets more at the nature of our universe. Because our universe is going for an equilibrium. That's why energy distributes from high to low, is that it's trying to reach an equilibrium. It's trying to distribute everything.
So that's almost like a form of intelligence.
You could say.
So everything trying to find the balance, trying to find the... Yeah, okay.
I've found in my life I'm a lot better able to handle things ever since I started viewing reality that way.
Really?
Whenever things happen to me, I do not define them as good or bad. I define them as simply something that has happened. My reaction to it is what's going to determine whether it's quote-unquote good or bad.
Which is all you can control.
Yeah.
Your reaction.
Yeah.
What happened, what has happened, completely out of your control.
Yeah.
Makes sense that, you can, but that also ties into the past, because ultimately you can only control the present moment, which in results going to lead to how you can't control your future. But the past, you can't let that nostalgia eat you up either, because you can't control it. It just is. Well,
yeah. If you live in your past, you're doomed to be consumed by it. It's just that simple. That's it.
Yeah, totally.
Yeah.
Wow, yeah. Well, if you want, we got hamburgers upstairs.
Whatever works.
Cool. Yeah, well, that concludes... we made 2 hours, damn. I love it. Well, dude, let me shake your hand. Holy shit, I'm literally fucking mind blown right now. I don't know how to describe it. Like, I'm definitely going to look up all these things, and because I think a lot of these, like I'm going to watch some YouTube videos on quantum entanglement. And we didn't even talk about neural pruning on the podcast at all. Damn, dude. You are a very smart guy. Wow. Wow. Yeah, well, that concludes another episode of Jordan's Subjective Perspective. If you listen this far, I appreciate your time. I really do. Do you have any send-offs, Joel?
Can I do a shameless plug right here?
You go for it. I don't even know what that means.
Anyone who is interested in keeping up with my journeys and my endeavors in life, please feel free to check me out on Facebook, Joel Geders, or my Instagram, which is way cooler in my opinion.
Hey.
It is at Joel Does Jitsu. And if you like puppies, fighting, or science, or just weird motherfuckers, go check me out. Or die.
Well, you know what I'm gonna do? I'll leave a link to anything you want in the description of the YouTube, and because I want to get this on the podcasting app, so I'll get on all of that, and I'll just leave the description like in there if you'd like. Your ad name and all that.
I just realized like we didn't even remotely touch on martial arts, and I figured that was like the most of what we were gonna talk about.
That's what I thought too. Yeah, we like barely covered that whatsoever. Like if you look at my notes, like that's what I mainly. I was also